This topic we will learn about Vander Waals radius. Vander Waals radius. Vander Waals. Vander Waals radius. Vander Waals radius. Non-metals are aggregates of molecules in solid state. In this state, molecules are held together by weak attractive forces, which are called Vander Waals forces. These forces are not present in gaseous state. These forces are not present in gaseous state. It is defined as half of the distance between half of the distance between the nuclei of two adjacent atoms belonging to two neighboring molecules. Two neighboring molecules of an element in the solid state is known as Vander Waals radius of the atom. Vander Waals radius of the atom. Half of the distance between the nuclei of two adjacent belonging to neighboring molecules of an element in the solid state is known as Vander Waals radius of the atom. This is the chlorine atom, and next this is the chlorine atom and chlorine atom. The distance and this is the chlorine point. Chlorine. This is the Vander Waals distance. This is the Vander Waals distance. And this is the Vander Waals distance, and this is the Vander Waals radius. This is the Vander Waals radius. This distance is 3.6 angstrom for chlorine, and this radius is 1.8 angstrom for chlorine. This is the Vander Waals radius, and this is the Vander Waals distance. So half of the distance, this is the distance, half of the distance between two nuclei of two adjacent atoms belonging to two neighboring molecules of an element in the solid state is known as Vander Waals radius of the atom. Vander Waals radius is non-bounded. Vander Waals radius is non-bounded distance of closure approach. It is greater than covalent radius. It is half its Vander Waals distance. It is half Vander Waals distance. Half Vander Waals distance. It is the distance between two non-bounded atoms of two adjacent molecules in solid state. The values of this radii are obtained from X-ray studies of various elements in the solid state. In chlorine solid, the distance between two non-bonding neighboring chlorine atoms is 3.6 angstrom, which is Vander Waals distance. Vander Waals radius of chlorine. Vander Waals radius of chlorine equal to 3.6 upon 2 equal to 1.8 angstrom. The Vander Waals radius of chlorine atom is given. Vander Waals radius of some elements. Group. Group 15, Group 16, Group 17 and Group 18. Group 15, 16, 17 and 18. 15 group, nitrogen, phosphorus, arsenic, Sb, bismuth. The Vander Waals radius 1.5, 1.9, 2.0, 2.2. 16 group, oxygen, sulfur, Fe, oxygen 1.40, 1.85, 2.0 and 2.20. 17th group, hydrogen 1.2, fluorine 1.36, chlorine 1.8, bromine 1.95, iodine 2.15. 18th group, helium 1.20, neon 1.60 and argon 1.21, krypton 2.0, xenon 2.20.